Jack,
John, how are you this morning?
very good, mate. Today, we thought we would look into discussing ideas around skill acquisition, motor learning, sensory motor control, how these things interplay, because we obviously spoke about running, but one of the areas that we didn't really address was if you identify, say, aberrant biomechanics, whatever they may be, in the kinetic realm, kinematic realm, how do you actually start changing that? And should you change that? I think we briefly spoke about whether we start changing some mechanics, but we didn't really talk about what you do if you are looking to change those. So today I thought we'd have some time to do that.
Yeah, sure. Well, I think it's a useful topic because we need to think about factors that relate to it, whether they be direct factors in terms of changing mechanics, and we can talk about cueing specifically and how we may use different type of cueing to induce or elicit different effects, but also thinking about other factors that are very intimately related to how we move, particularly with sensory motor control, and thinking about things like tissue capacity and what you and I talk about in terms of hormetic profile, which encompasses a lot of different things, which we'll talk about.
You just mentioned sensory motor control. And in our realm, particularly in physio, the word...
Why is it that we smile as soon as we say that?
Because we always have issues with things because we think that people say things and use terminology that we believe they don't really understand what they're saying.
Yeah.
And motor control is one. That seems to be a catch-all term for utilization of segments of movement, different types of movement, the quality of the movement, muscle activation, patterning, all these kind of things, but it's often not used correctly. And I know that the term that you tend to give a lot of feedback to our staff here and people that are understanding is really starting to get an idea of sensory motor control. So do you want to give our listeners maybe an understanding of what sensory motor control is? Because if you look into the literature and the body of literature, they don't talk about motor control a lot. It seems to be something that gets talked about in physical therapy, but they talk about sensory motor control. And what's the difference and what actually is it?
Well, it encompasses not just the output of the system, i.e. motor, but also the input of the system.
Look, I think this is something that if you look at neurobiology, this is something that they've been talking about for a long time. This idea that perception, and whether you're thinking about that from a psychological standpoint, like I watched something actually only the other day that was looking at perception and how we don't actually see objects, we see meaning. And I think that that's a really important factor because it significantly alters what we do in terms of our response. And I think that's probably part of the crux of what you're getting at is you need to be able to sense what is going on before you can appropriately react or create some sort of motor learning.
Well, I think you also highlighted a valuable point is even sensory motor control, we need to be careful of not reducing it down to thinking that this is like a purely bidirectional response of like input-output. Because the reality is there are so many factors along the way that determine how you interpret that input in terms of integrative factors. So like, executive function, your mood, your arousal, neurotransmitter status, things like that. And there's a lot of environmental factors there too, because the behavior of the sensory motor system is going to be dependent on the context of your environment. So whether you're in like a closed environment, say, running in here is going to be very different to running in the final of Olympic race. Yeah,
and that's interesting too, because I know that like in the past, and for people interested, I think some of the work of Paul Glazier is very relevant with this. He talks very much around the interaction that occurs, within the organism. And in that paper, particularly the one about like unified sort of theory, he talks a lot about the idea that the environment has a really big influence on what actually the output will be.
Yeah, and Daniel Walpert talks a lot about this too.
I know you brought up Daniel a lot. I think for our listeners, there's some really good videos. Is it on YouTube or
He's got a few on YouTube. Yeah.
There's one on, is it even a TED Talk?
There is a TED Talk as well.
Yeah. All of those I think are really relevant and valuable for people because he starts to really put together these pieces, as you said, of like the interplay and not just this information going in, but what's actually happening within the different parts of, say, the nervous system for that interpretation to even occur.
And extending beyond this simplified idea of it's just purely an engineering problem of like a circuitry thing that
it's like this wire connects to this wire. It's not that.
It's a bioengineering problem. And what I mean by that is, we're not simple systems. We're actually quite complex systems. And we've talked a little bit about this before, but we need to essentially look at the sensory-motor system as a confluence of factors that are interacting with each other in a dynamic fashion that creates changes over time. And that makes a lot of sense when you just even think about how you felt when you woke up this morning affects your movement patterns compared to yesterday, compared to tomorrow, because of, you're deprived in sleep. You've maybe had a few drinks last night.
Yeah. And this is the thing, it doesn't necessarily mean the output is diminished. It's just that our sensory feedback that we're getting is different. And it sometimes will cause a decrease. It might sometimes also cause an increase. But I think some of the really basic examples you would give is, especially if we go back to our example from running, if it's a nice sunny day and it's a moderate temperature, you feel very, very good about how you're going to approach that situation and the output that you're going to give.
Absolutely.
If it's -2, like you said it was to me this morning when you rolled out, in the car, it's a very different proposition to how you're going to approach it. And the motor output that you will give is going to be heavily influenced by that temperature and environmental change.
Yeah, and look, going back to your initial question, because I don't think, just to define it more clearly in terms of sensory motor control, we currently see an issue within our profession where motor control is a very vague and ambiguous term, and typically a lot of physiotherapists, I think, associate it with a muscle turning on or off.
Yeah.
And this is this idea from some of the research originally done by Gwendolyn Joel of looking at delay in certain muscle activity, particularly in like chronic pain conditions, particularly like say lower back or neck pain.
Yep.
It's interesting to note that seems to be a particular definition that's stuck within our profession, and there's been no consideration for all the other factors that have been identified in sensory motor system. Because like I look at, say, the Stuart McGill model in comparison, it's almost completely contradicts some of that idea of like, it's not about the small localized muscles that control stabilization. It's actually the large muscles that we need to consider because their capacity to produce force and therefore stabilize the system is far greater.
Yeah, well, that always makes me think of, and I know that he came out with some smart-ass papers, but that James Newzo did publish that paper looking at activation of transverse abdominis, but also of all the other surrounding more global muscles doing, say, like a deadlift versus these like specific tasks. And there's clearly much more utilization of that tissue, much more EMG activity, much more even force transmission and tension created within the tissue by doing the much bigger tasks. And the argument was that like you're much better off if you're trying to create change from both a neurological input, but also from a mechanical tension standpoint and trying to create, say, tissue change.
Yeah.
You're better off doing those larger global exercises because you're getting much greater magnitude of both of those stimuli.
Well, and I look at it too from the perspective of it doesn't seem to make any evolutionary sense that we, quote unquote, lose the ability to recruit certain muscles in the presence of pain. Like unless you've got some type of neurological condition where you've actually created
I think that's the big issue. And we've spoken about this before, but I hate the term activation. And I hate it in the sports performance realm where people saying, oh, in our warm-up, we're doing activations. And I know the other day you said, oh, isn't that just a warm-up?
Yeah.
Right? Clearly a warm-up, if it's integrated properly, is going to be upregulating both peripheral and central nervous system functions.
Absolutely.
It's going to be increasing the amount of recruitment that's occurring, within the motor units. It's going to make sure that the tissue temperature is high enough so the enzymatic function is good.
Sympathetic outflow.
Of course, all of these different things that are important for actual function of tissue and movement. That's what a warm-up is. This idea that you're preferentially activating it by doing, and usually they're quite low-level tasks, never makes any sense to me. So, and even using the term, I think it's not accurate for one, because as you said, tissue, it's not like it all of a sudden turns off and then you can't get it back on.
Yeah.
And two, it doesn't really separate from an integrated warm-up. Absolutely.
Yeah. And look, if you look at there's actually quite an interesting paper from 2018 by, I can't remember his first name, but the surname is Lowe, of looking at all the different definitions of motor control. And you look at them and go, okay, wow, One, we've got a lot of different definitions that often compete with each other.
Yep.
And I know we've talked about this before, but when you have evidence that supports contradicting hypotheses, you know you've got a complex system.
Yeah.
And that's what we're
complex
dealing with
problem,
when it comes to humans. I think the issue we currently face is, do we need to look at sensory-motor system as trying to alter the input with using internal cues, or do we want to think about the multitude of factors that influence sensory-motor control, think about how we can change some of those modulators or factors and see changes to the output over time? And so to put this in the context, at the moment, there's still this embedded belief of we need to use internal cueing to recruit certain muscles. And it's actually interesting to note because there are studies showing that if you use particular internal cues, you see an increase in EMG activity of a muscle. Now, the funny thing about this is actually something that's very well established when you look at all the motor learning literature, whether it's sort of Gabriel Wolf stuff or Winkelmann stuff, where we actually know that if you say, all right, I want you to focus more on an internal cue, whether that's, some type of cue to utilize the abdominal muscles, whatever area of the
gluteals,
body.
Something around the rotator cuff, which is typically what it will happen in the physical therapy world.
And what's interesting to note is, although you see an increase in EMG output, you see relative to using an external cue, there's less force production.
Yeah. So the actual, and this is good because this kind of gets into where we're going.
Yes.
If you're trying to get changes in movement, you've got to at some level be affecting what we spoke about in the discussion on running, factors relating to kinetics, kinematics, or spatiotemporal factors. So if you're getting a force reduction, you're actually reducing the kinetic output, right? Therefore, it's less likely that you're probably going to hit the right kinematic position, and your spatiotemporal factors will also be decreased. So by utilizing, as you said, an internal cue, you may actually be setting them up to not be able to create the biomechanical output that you desire or the person desires for their task.
At least I think in the mid to long term, and we've talked about this before, but it's not to suggest that internal cueing doesn't actually have value.
Of course, it does,
when you use an internal cue, i.e. you're focusing on something within the body, it's going to bring attention to that region, which then may be able to get you to change how that region works within that whole kinetic chain. That might be a really useful thing. So I often look at the analogy of, let's say you've got 200-meter runners. You'd see this all the time. Let's say they're good runners, they can run 10.5. If you watch how they actually run, they may achieve the same outcome using a very different pattern. In terms of, say, their acceleration versus max velocity, but also the actual mechanics of their movement. And we can actually start to break down, well, why is there a difference in their movement patterns, even though they're actually producing the same outcome? You start to identify that they have differences in their flexibility, strength, power, elasticity, or even just how they're being coached and what they've been focused on. So we can already see that you've got differences in the actual way that they achieve the result, even though they end up with the same result. And this is where I think it's really useful to think about the sensory-motor system of going, well, why is it someone utilizes that particular pattern to achieve that particular movement task? And we can start to identify very quickly about whether there are biomechanical factors. Do we actually need to coach them and use some type of cueing to create changes in how they move? And again, we can think of whether we use internal cueing to create more region-specific things. Do they need to focus on hip drive specifically? Do they need to focus on ankle stiffness? And then this is where I think we need to also expand our understanding of motor learning, that the mechanics of movement is also greatly influenced by the person's tissue capacity. So when we look at their overall profile of region-specific ability with flexibility, strength, and so on, those factors are going to determine input to the sensory motor system and let the system go, okay, how am I actually going to achieve the task at hand? How am I going to run as quickly as I can from here to here with the tools I have available?
And that's the word that we always use, that idea of the more tools they have in the tool bag, when a situation presents, they have the opportunity to use an appropriate tool for that situation.
Absolutely.
So, and that's where I think it's important that as you do get those environmental changes, as we suggested, there is opportunity that, say someone comes to tackle you in a field sport, if you actually have appropriate evasive skills, and that obviously there's lots of components that go into the ability to react in an agility task. But if you have those, you can then pull that out.
Yes.
If you don't have those capabilities, it's not going to happen.
Yes.
And to probably give a more clear example is if someone has the ability to create very high eccentric forces in a landing, and they are able to, say, for instance, stabilize when they do land from, say, a height or a change of direction, the likelihood that if they're able to evade someone is going to be much higher than if they don't have those high-level eccentric capabilities within, say, their lower limb.
Absolutely. And in real time, that's happening at a subconscious level.
Yes.
You know, like everything that we do behind the scenes is essentially to provide as many tools as possible for them to give them better solutions to, in that situation.
And so, at a really simplistic level, I always think that, in terms of the biomechanical outputs that you observe, and that's, that gets more complicated when you start to look at it as a sensory motor output. But it's very much, what skills do they have and how do they understand how to actually carry out that skill, plus the, the biomotor abilities that they actually have. Those two things will start to work together to create that biomechanical output.
The other interesting thing too, like using the example of, say, a field sport, there is so much uncertainty in terms of what's going to happen.
Yep.
So you actually need a level of complexity and variability in movement.
Yep.
Because the reality is, if you go to change direction, it's going to be different every time based on the parameters you're
ground surface,
angles,
temperature,
whether it's wet or not, where the opponents are located, the speed at which you reach that point.
Fatigue.
And interestingly enough, too, when we think about particularly motor learning, external cueing is shown to increase what they call entropy, i.e. less predictability or more variability in movement, which I think a lot of the time people will go, but do we want that? Do we want more variability? And the reality is, in very complex environments where there is uncertainty, you do. You don't want this idea of almost like robotic maneuvers. Yeah,
this perfect execution of some sort of motor skill.
Absolutely. Maybe you do you think that you want more of that in, say, sprinting, because there's actually more.
Look, I think you shift more towards that, but you do still want the capability of having variable performance. You want the ability, if it's a headwind versus a tailwind versus cold, whatever it is, they need to be able to carry it out in a way that's effective. And for events that have, say, tactical input, can you change pace? Can you not change pace? All of these kind of things are really important. And so you need to have some level of variability in what your skill set has so that you can carry out that level of variability when the opportunity presents.
That also makes a lot of sense to me, just in thinking about this now, of just from an injury prevention standpoint, because even if you're in a more constrained environment where the task is very repetitive, just because of the fact that we see variation in the sensory motor system based on many things, if there is a change in the system that if you're then trying to complete a task in a very specific controlled manner, but you're unable to because you feel a little bit stiff because you did a heavy resistance training session a few days ago, do you actually increase your susceptibility because you haven't been able to
And I think this is the discussion, remember, we had around flexibility, and we said the reason that range of motion and flexibility is potentially valuable as a mechanism for reducing injury, there's obviously lots, and we kind of alluded to some of them, but is that it gives you more degrees of freedom in a variable situation.
Yes, and that may not always be evident in the macro biomechanics, because you might see but they're getting their knee to the same position and so on, but when you look at the actual
they've had to change their hip or ankle position or
and even
their
what's
torso,
happening at the muscle tendon
even if you go deeper,
absolutely, because when do soft tissue strains occur? It's usually when the strain exceeds the capacity of the system. And if you overstrain a particular area of the muscle tendon unit that's not familiar with, that's when you're likely to get failure of the system. So I think that's the other thing to consider too, because the reality is what's happening at the tissue level is also going to vary as much as what you see at the macro level as well.
And I think having that variability and exposure to that variability, as you said, in the task that you do at the tissue level is important. And I don't know that we always think about that. As you said, if you're consistently giving these cues, this is what I used to get really frustrated as a younger clinician, saying, all right, you've got to feel for this turning on or whatever it is. Oh, no, you didn't do it properly. Stop, go back and do it again. And I always thought, as you said, that's such a constrained, closed environment that doesn't make a lot of sense to me when they're going to be running at 9 meters per second with someone trying to tackle them. And the tissue needs to have capability, even as you said, even at the tissue level, to be able to respond in a different manner.
Absolutely.
Where it requires, as you said, more tendon stiffness versus, muscular contraction, or vice versa, or it needs more compliance within a certain movement because it's going through, a large range. And people sort of don't think about that. But if you have a think about, for our listeners, if you're thinking about, say, like someone kicking, we know that we will always use very slight variations, particularly someone who's very skilled with kicking. They'll use very slight variations in the amount of tension or the amount of force or the velocity at which they're actually imparting onto the ball. And that's going to change the actual mechanics that's happening within the tissue itself.
It's funny you say that. I was actually reading it's a book by David Ben, who is a researcher in Canada. He's done a lot of research in flexibility, and he wrote this book called, I can't remember the title specifically, but it's like the physiology and mechanics of flexibility and stretching. And there was a quote in the book from an author, what's that Irish name? Malachi? I'm not sure how you pronounce it. Malachi, is it?
Malachi. all our listeners called Malachi are going to be tearing their hair out. You butchered that one.
I did. I tried, but I failed. Malachi McHugh has written quite a bit of research on flexibility too, and understanding stiffness and muscle tendon behavior. And he actually used the analogy that years ago in soccer or football, European football, when they used to have the leather ball, when it was wet, the ball became a lot heavier.
Of course, yeah.
And he made a really interesting point. He goes, muscle strains can occur during concentric contractions in shortened positions. And he used that example that when it was wet, footballers used to kick the ball
and hurt themselves.
And as you can imagine, when they're swinging through, the rectus femoris is actually shortening.
Yeah.
And it's shortening as you flex through the hip. They kick the ball and they blow out their rectus femoris.
Yeah.
And what's actually going on there? It's like, well, the problem is they've underestimated the change in the variable, specifically in this situation.
And that's that sensory input. Completely. Because if you haven't made that adjustment about what the ball's going to feel like, the weight of the ball, the force application, the way that you're hitting it needs to be different. But as I said, if there isn't that match, there's potential opportunity for failure of tissue to actually be able to tolerate that.
Well, this is it, isn't it? It makes you realize that we're getting into really complex areas when you think about how the neuromuscular system coordinates the recruitment of different parts of the muscle at different times to take that into consideration.
I always think this shows just how impressive the human and particularly human movement is. And I know that Daniel Walpert actually argues this, that
the reason why our brains are so big is purely for being able to coordinate through the environment.
And such a complex movement that we actually do have the capability of managing. That to me is just so impressive because, as you said, it suggests the level of understanding and manipulation that we don't consciously even need to be aware of, but we can make those adjustments.
Well, and I think that's the thing that we need to consider, because we're not thinking about what we're doing right now. Like, our sensory-motor system is perfectly intact and doing what it needs to. And it's something that I think we need to be critical of when we think about, well, how do we address the sensory motor system? Because if we constantly constrain it to thinking of it just being related to one particular thing, for example, using internal cues, you may not see the actual change and adaptation you expect over time that allows that system to build resiliency.
Right. Well, I think that gives people a bit of a background, and I think that feeds in nicely to us talking about how do we actually make change.
Well, this goes back to what I suggested to begin with. So we can actually start with looking at the mechanics of the movement. I think that's probably a useful thing. So we can obviously, let's use running as an example, something that you obviously know quite a bit about. We can develop models of what is, i.e., optimal movement patterns. When we look
or a similar-ish model that we think is close to that, more optimal for that individual.
Correct. And everyone does this, particularly if you work in sport, whatever sport you work in, you start to get familiarity with the mechanics of a tennis serve or a baseball pitch or cricket bowling, whatever it may be. And obviously, the more you get exposed to it, the more you start to understand what are the specific kinematic components to it in terms of joint positions, in terms of joint contribution, and so on. So we can look and observe at someone's movement pattern and go, how much does that vary from what we consider to be the optimal movement pattern?
I think that feeds into the discussion we had before about their biomotor abilities.
Mm.
If you go through a particular skill and you actually identify, okay, these are the kinematic features, that straight away tells you've got to start looking at, say, their movement capability. Can they actually even achieve the position that you want them to achieve?
Yes.
If you're asking someone to throw or pitch and they need to have a certain amount of shoulder external rotation with their shoulder already in some level of extension, and they don't have that, how do you expect them to do it at very high velocities and under, very high forces? It's clearly going to cause some sort of tissue damage.
Well, it's funny. I think that's often overlooked. Another great example is squat mechanics and looking at ankle dorsiflexion and hip mobility.
Yeah.
Where, if someone can't achieve that position, then you need to address their underlying movement capacity so they can actually reach those positions.
Yeah, and we spoke about this. It's often going to be worse when they're under tension. We spoke about it in the flexibility discussion, that it's not always the case because sometimes people are able to create more stretch on a tissue under higher speeds and velocities.
Yes.
But typically, they actually often, when there's tension within the system across the chains, you'll actually lose more range.
Absolutely.
So even if you do an isolated test and they don't have the range, expect that it probably may even get worse under some level of tension throughout that whole chain.
Yeah, and this is a really good basic example of looking at the relationship between tissue capacity and biomechanics, because we're going to see similar to when you think about like the relative strength of gluteals versus, say, quadriceps in terms of the movement pattern someone creates, particularly with like looking at, say, trunk position again with the squatting movement. We certainly see that a lot when you look at, say, frontal plane mechanics with, say, single leg movement, particularly related to hip strength. So we see this relationship straight away, and we also see the same that when you actually build those capacities you identify as deficits, you get that reorganization of the system to take into consideration, okay, now we've got more movement in the ankle and the hip. Now we've got better strength capacity in that region and changes in their movement patterns. Now, that may not always be the case. Like there are going to be times when you go, okay, I actually need to give them specific cueing to focus on particular areas of the body. But it also highlights that ability for the system to self-organize based on, again, the tools it has to solve the problem.
In terms of how you would go like from there, so say for instance you've done your kinematic analysis, you understand what the movement is. What are our options when we want to start making changes? We identify, okay, that person, actually this leads to something, I always get this question of, should you change someone's mechanics? We spoke about it briefly in running. I think it always comes down to bandwidth.
Yes.
It's like someone will get away with a certain amount of variation from what you would consider the model pattern or, say, a level of symmetry. However, if it starts to cause issues, then they're outside the bandwidth that their tissue can actually tolerate.
Yes.
And it's always this balance. If you have a lot of tolerance in terms of your capability within your tissue capacity, so you have lots of range of motion or you have very high strength or very high power, you can probably get away with more variation in the amount of the movement, say, expression that you're giving. An example would be, so the people who probably, and he did have problems, but if you look at, say, someone like Sean Tate, who was a fast bowler for Australia.
Really tall guy, wasn't he? Yeah.
Tall guy, but he used to have a very low, like, sling type action.
Yes.
He did have elbow problems because of it.
Yes.
But big guy, very strong, very explosive. He got away with that action in a relative sense. He paid for it because of obviously some of the injuries that he had, but he paid for it. He got away with certain aspects of it for a reasonable amount of time because he had such power and such strength and, as I said, was a big frame. So he could actually tolerate those kind of forces outside what people would say is a classic, tidy, smooth bowling action. If you compared Sean Tate with one of the legends of fast bowling in Australia, Glenn McGrath, one's, smooth as butter and the other one, is horrible to watch. But they were able to get relative success in what they were trying to achieve. And as you said, huge variability in the skill output, but the actual performance still achieved a reasonable sort of similarity. And I always think about this as like, how far are they away from that model? And if they are far away and they don't have the tissue capacities, it's a recipe for disaster. As that you may get away with it if they have some of those things. But you're also at that level putting into question how long are they going to tolerate that for, particularly as the volume of training or the training stress goes up within someone's, training, career and their sporting career.
You make me think straight away of like, when we talk about this, how do we actually apply it clinically? It makes you think of, I think it was 2 years ago, as I've probably mentioned before on the podcast, I do some lecturing out of La Trobe Uni. We had a school meeting, a physio school meeting, and we actually talked about the sensory-motor system, sensory-motor control, and what it actually means. And the consensus that came up with all the different academics and researchers there was sensory-motor control is the outcome or the process in which someone completes a movement. Which, when you think about it, that's quite a broad, general definition. But it actually highlights what I think it exactly is the sensory-motor system is just simply the product of that person's ability when we think about internal and external factors. And when I think of it from the perspective of what we do, that's essentially what we're trying to identify. When someone comes in with an injury, there's obviously the first thing of thinking, well, what is the injury? But very quickly, you transition to going, well, why did they get injured?
Yeah. And even I think it even goes back further to that discussion that we've had. I don't know if we've spoken about it on here, but, like what actually is an injury?
Yeah, well.
And I don't think a lot of people spend the time, particularly in musculoskeletal injuries. Really, what it is the inability to solve a motor problem.
Yes.
Now, that might be because of some sort of tissue pathology or insufficiency of that tissue to create that, motor output. But really, you can't solve a motor problem.
Yes.
And your job as a clinician is to work out what components do I need to actually put together so that they can go back to solving that motor problem and hopefully not end up in a position of damage by, restarting that activity.
Yeah. And it's clearly a dynamic process, because why did that person injure on that day and not the day before or the day after?
Yeah.
And again, that's because their sensory motor system has changed based on potentially many factors indeed. And that probably brings us to the last thing we need to consider with regards to sensory motor control is thinking about that person's capacity to deal with stress. And this is something that you and I often refer to as hormesis or hormetic profile. But I think the other big one we need to consider is fatigue too. And this sort of goes back to some of the stuff that Tim Gabbett has really been highlighting with regards to physical training loads. But we also need to extend that on beyond just the actual physical factors, but also non-physical factors when we consider things like psycho-emotional stress, sleep, diet, and so on.
Yeah, and we know that, even if you look at the pain research, that if you're sleep deprived, your pain perception goes up. Same thing happens with fatigue. And I know that a lot of the work by, say, Samuel Marcora in terms of fatigue show and the performance output shows that all of these factors have big influences on your perception of how hard you're working.
Yeah, absolutely.
And that's really going to change your motor output. That's going to change the way in which you actually carry out your skill.
And your ability to
endure that, as you said.
And to go through your motor learning process too is also reduced because your executive function, your actual capacity of the central nervous system, the state of it compromises your ability to actually learn a new task.
Yeah.
So I think that's also another really big thing that we need to consider.
Well, I think that's always really obvious to me, particularly with my group that I coach.
Sure.
When they're fatigued, technical things go out the window, and it's very obvious when someone is clearly, their training load needs to, be modified at some level. Is you're trying to teach some sort of skill, and they've almost lost coordination, and you're like, okay, you're tired, you need some rest.
Well, even too, look at field sports like AFL or rugby. When do injuries occur? They occur towards the end of half time because they're under level of fatigue.
Sometimes that's not always the case. Typically, you can also get them early in performance as well because of the speed of the game and whether the warm-up's adequate and all of that kind of stuff.
Absolutes are rarely true, but it's actually quite a common occurrence. And what does that influence? It influences that under fatigue, the sensory motor system changes where all of a sudden you might see changes in their mechanics again, but you also will see changes in the behavior of the muscle tendon unit, which we know. Yeah,
we've seen that multiple times in your sprint. Your repeat sprint ability, and how that changes very much based on the exposures and fatigue and what that does to the actual mechanics of the tissue itself.
Well, absolutely. If you look at say hamstring strains, we know that under fatigue, it's actually semi-tendinosis that's going to fatigue much more quickly. And that obviously is going to change the behavior and actual load exposed to biceps femoris, which typically is
the most common.
Commonly injured.
All right.
Hamstring.
With that in mind, like we start obviously then to think about, okay, we've identified these things. We're going to try and make some changes. And one of the things that I think is very obvious, but it comes from the fields of learning and pedagogy, and it comes back to, all right, if we're teaching a skill, we have to think about it as a learning process. How are we going to structure that learning process so that we can actually optimize that person's ability to pick up that motor skill?
Well, actually, I'd be interested. I think you're probably better positioned to answer this than I am, because you obviously deal a lot with teaching running as a particular skill. So how do you go about approaching it? Well,
I think it's one of those things, and this is probably one of the areas that I don't know if I differ from a lot of coaches. I think a lot of coaches do think about this, it's probably something that I make a mistake with often, but you have to consider that even with something as simple as running, you need to be trying to execute the skill at the highest level possible.
Okay.
And there's a lot of, particularly in our sport, there's a lot of people go, well, running's running, you just let them run. And the reality is, if you do that, they start to shift away from, say, potentially, as we spoke about, that model that you might be working towards. It's trying to optimize both kinematic, spatiotemporal, kinetic features that you think is going to, create the best performance possible. And even if you look at some of the work, I think I was rereading some of the stuff from Mule, who did a lot of research in this in the 80s and 90s. And one of the things that they came up with is the idea of the learning of skills is very much follows a power law, in terms of, say, an equation. And what it basically means is the more practice you do, the better you get at that skill. And we know that if we look at even, I'm sure a lot of people are probably aware of, the work of Anders Ericsson, who I think was in the 94, I think he published a paper that was done on actually violinists in Berlin. And that became really popular because of Malcolm Gladwell's book. And Anders actually didn't ever say 10,000 hours.
Yeah, so, I've heard that.
But that's something that Malcolm kind of jumped onto. And a lot of people talk about this 10,000 hour rule. And it's kind of gone back and forth with a few different writers. You and I are obviously a fan of someone like David Epstein, who kind of pushed against some of that. But essentially, the notion is pretty clear that if you want someone to get better at something, they need to actually practice that or some part of that skill. And the more they do that, the reality is it's likely to get better. There's also evidence, then that starts to ask the question, okay, well, then how do I expose them to that? And it's like any training. The idea you would think about is how much stress can they tolerate? We spoke about this in the periodization, how much stress can they tolerate in one sitting or across a week is similar to what you would do in terms of the exposure to skill and to learning. And we all know this. Everyone's on school. Everyone's, a lot of people will go to university. You can't concentrate for 7 hours, in one stint without any breaks. So the evidence is there, even in skill acquisition, that distributed practice is more effective than, practice within one big block, which seems pretty self-evident. And that may mean, for instance, you exposing someone to that skill across a week multiple times, rather than saying, we're going to do 5 hours today instead of doing 5 1-hour sessions.
Yes. So you need to be pragmatic about it, too.
Yeah, but the evidence is there to support that. So distributed practice is more effective than whole practice if it's, carried out across a period of time, whether that's within a day or across a week or across months, whatever that is. The more of that you do, though, the more likely they are to pick up the skill. The other thing that I think then you need to start thinking about is, okay, well, we know that's given us our more macro structure of, okay, we're going to try and expose them to it multiple times. I'm going to do it often. Then it gets into some of the things that you started talking about, which are, okay, well, how am I going to start creating that change for that person? Am I going to give them, say, cues, whether they be internal or external, which would be, they would consider explicit instruction, or an explicit sort of style of learning? Or are we going to use a more implicit approach where they're picking it up through exploration of their own, whether it's environment or the exercise that you set up for them. And that's the interplay that you need to start thinking of. And particularly in the area of education, and I know even like in physical education, they talk about, a couple of different approaches in that implicit model, where it might be things like setting up games and exploring through the, gameplay. And what you do is you design the game so that they actually are able to explore different skills in order to be able to learn and get that variability of performance around that. Yeah. Then there's obviously a model that's become really popular, which we use a fair bit, and I use a lot in terms of my coaching, is a constraints-based approach. And it's become really popular in coaching because, well, we probably should explain what a constraints-based approach is. Do you want to? I've been talking a lot. Do you want to give people a bit of an idea on what constraints-based learning is?
Well, I think Paul Glazier talks a lot about this in particular, and the constraint-based approach is simply that of thinking about how you apply constraints to a particular activity so they can focus more on particular elements within that activity.
And I always think about it of like, in a really simplified manner, it's like you place obstacles in front of people to get the outcomes that you're hoping to get from their skill execution.
Yes.
So a silly example that I gave in a presentation that I was doing was when you're trying to teach someone long jump, typically one of the big factors that they have problems with in the takeoff is they don't create enough height, right? Because it's a bit of an unnatural thing to be able to convert horizontal momentum to some level of vertical momentum in the jumping. What you'll do sometimes, particularly with young people, is you'll put like a hurdle, it might not be particularly high, in the pit and say to them, I want you to actually jump over this. Because it teaches them they've got to create some level of vertical, displacement from their run. And what you're doing is you're putting an obstacle there. It's a constraint for them to have to actually get around. You don't need to give them any instructions about, I need you to drive your knee, I need you to do this. You just say to them, I need you to jump over this. I'm going to put this here, I need you to jump over it. If they do it enough and they start to figure out within their own sort of like exploration of that, how to create enough vertical momentum, they'll then be able to do it and execute it. And it's probably given them enough exploration with their own variability in terms of what cues they give themselves to be able to then implant that learning at a much deeper level. And there's always this talk about how implicit learning tends to create much more consistent and significant kind of like you retain it for longer, for instance, in terms of the learning, rather than with explicit learning where you're giving, say, direct instruction. And most of us would be really aware of explicit approach to learning. The coach, the clinician, the teacher says, this is what I want you to do. This is how I want you to do it. Here's the demonstration. Here's the instructions. That's explicitly telling you it's direct feedback. It's direct instruction. Whereas in the implicit style, it's like, here's a problem. I want you to kind of navigate your way through it, whether it's a game, whether it's a constraint, whatever it is.
And part of that then too is how much autonomy do you want to give to the individual versus using that constrained action hypothesis of this is exactly what I want you to do. And that's probably worth also separating too, because we can think of external, internal cueing where it's.
Well, I think this is really valuable.
Yes,
because I think the thing, and as I said, I was lucky enough to meet Nick Winkelman, who did his PhD on internal versus external cues in sports performance stuff. I think he's at Irish Rugby now.
I think he is. Yes.
Yeah, and he's a great guy. Really interestingly, like his research showed that if you create external cues, and as you mentioned before, you can actually get greater outputs in biomechanical features or mechanical tension, whatever it is.
Force output, accuracy.
Yeah. And an external cue would be something like, as you said, I want you to push the ground away from you in an acceleration, rather than saying like move your leg here or lift your hip or you squeeze with your, or fully extend or whatever it is. You just tell them, I need you to just push or whatever that external loci might be.
Is the focus outside of the body or is the focus inside of the body?
And what's interesting about that, and I think the nice thing about something like an external cue is I sort of see it as almost the bridge between implicit and explicit learning, because you're not telling them how to do it. You're not giving them direct instruction. You're saying, I kind of want this outcome. I'm going to give you some sort of idea of how you're going to do that, but I'm not going to give you the answer of like an internal cue of like, you need to squeeze this or you need to push that muscle.
What you're actually highlighting here, I think, just thinking about it now, is the idea of internal versus external, implicit versus explicit, depends on where you are on that spectrum of self-focus versus autonomy. Because
Yes.
like, what is an internal cue? It's as much self-focus and direction as it can be. All I want you to do is focus on your hip and squeezing your glutes, or whatever it
and
may
pushing
be.
up. Like as you push up, you've got to think about your hip flexor or whatever it is.
And look, that's a question I was going to ask you from your experience in coaching. Do you use internal cueing, and if so, when do you think it is valuable or appropriate?
Yeah, you do use internal cues, and I think this is the thing that's interesting. Over time, I've learned, and I would say I still fail at this often, where giving like explicit feedback and giving internal cues is easy.
Yes.
Giving external cues and giving constraint-based approach and implicit kind of learning environments is actually more difficult because it requires a lot more thinking on your part. It requires you to actually come and be creative, to think, how do I set up this environment so I get the outcome for this individual with their own, as you said, sensorimotor, map and understanding? How do they actually solve that problem? I've got to come up with some sort of exercise that actually is relevant for them.
Yeah.
And so you do fall into that sometimes. You go, just move this here because it's easy for you, I think. What's more difficult is actually saying, okay, well, how do I set this up so that they can find their own solution to, and everyone knows this.
But because the other issue I guess you fall into is, does an individual become too dependent on you if you're actually providing all the feedback all the time?
Definitely.
They actually don't develop the ability for self-awareness and reflection.
Definitely. And that's, one of the challenges that you face when you're trying to sort of put these things together. But over time, I've tried to create more of these constraints-based approach so that they can explore more of this themselves. And I think the thing that I would say, and this is a caveat, and I remember when I actually met Nick Winkelman, it was when I was in the US doing some coursework, and at the time, actually one of the top sprint coaches, or actually track and field coaches in the world, sort of pushed back a little bit on him and said, well, for someone who's got quite good knowledge of their body and has pretty good understanding of, say, anatomy, internal cues can be more effective than external cues. And I think that's kind of the thing that happens is as someone becomes more experienced and as someone's knowledge increases as an experienced, say, athlete, or it could be in an occupation, it depends on what it is, but they're really experienced within that domain of that skill or movement, they will have a better understanding of what physical features need to happen at, say, a joint or anatomy or a tissue level. So it's not that you should always do that because I think, as you said, that creates that internal focus too much.
Yeah.
But they have a better understanding of it. So they can actually speak with you at a level that will give you, I think, a more holistic or rounded approach to how you're applying that problem. Because you say, okay, you can, and this is where with coaching it gets even more interesting. And we've spoken a lot about John Kiley, and I really like his concepts of, you've got to bring the athlete's autonomy level back into it. And for those who are interested, there's lots of theories around motivation, but one of them is obviously self-determination theory. And it's one of the central components of self-determination theory is, autonomy. So giving the autonomy to that individual to understand how they're going to be part of that problem-solving process can happen as they get more experience. So with the more experienced athlete, say, okay, your knee's not getting to this position, which is limiting how much force you can apply to the track when you retract your leg. What kind of cues do you think we can use, whether they're, and typically it's external, or what type of exercises do you think are going to give you the feedback that you need? So it might be something like you take someone out of an acceleration to a bound type task and they know why you're doing it, but you're trying to give them that feeling of creating much more retraction and force application. And you might do that over hurdles or cones, or you might ask them to do a certain thing so that they can then create that map of, all right, how am I going to navigate this problem?
Yes.
That obviously takes a lot of experience on your part and a lot of experience on the individual's part, but bringing them into that process, if they have the understanding, I think is something that it's fun to do, and it's actually probably more enjoyable for them and for you. It really does bring that idea of autonomy for them from a motivational standpoint, but also I think it's the thing that happens and demonstrates to me that internal cues are not useless.
No, and there's a few things I was going to see your opinion on, because my assumption would be with internal cueing too is in the training or learning environment, it can be a valuable thing in certain contexts, in certain circumstances. But because of the issue with internal cueing, where you'll typically create a lot of co-contraction of not just the agonist but antagonist, which is probably one of the big reasons why you get a reduction in the actual force output, you want to only limit it to that constrained environment. When you're actually in, say, more a competitive or open environment, such focus on cues may actually compromise your performance.
Definitely.
Yeah.
Yeah.
But I was going to ask you though too, like particularly in say sprinting, where because you don't actually have so many external uncontrolled variables like an opponent, do you get athletes, or do athletes in general focus a lot on still external cueing for execution? Or do you think when it comes to competition, it's like all the preparation that you've done before it leads to the point where when it comes to race, you just go?
No, I think you can actually do those things. And it's funny because if you talk to really experienced coaches and particularly really experienced athletes, they'll tell you that they have the ability to think a lot during even very short races like the 100 meters.
Yeah.
And I think the better ones have a lot of clarity about what's going on. And you and I have discussed this before, but I think really good athletes, it's generally one of the skills that they have that puts them on a genius level in that domain. Like I remember we've spoken this conversation. I think I showed you, there's an interview with LeBron James where someone asked him like, oh, what happened at this point? And he like literally play by play said, oh, I passed the ball to this guy and then he gave me this. And then I knew that he was like running there and I did this. And it was like in the 4th minute of the game. And this is in the press conference. And to think that his recollection of that was so clear shows you the level of perception that someone like he has. And it's no surprise that he's been not only one of the best players of this whole era, but also for a really long time.
Yeah.
And I think the same thing happens in sprints. And obviously in distance running, you've got plenty of time to think. But in sprints, the same thing happens. It's like time slows down. So you actually have the opportunity. And you might use external cues. So for instance, like in the acceleration, it can be as simple as like, all I'm thinking is push. Yeah. Like just push.
Yeah.
Right? You're not thinking, oh, my arm goes here.
Yeah.
Oh, my ankle
Is my
needs to do
glutes
this.
working?
Exactly. You're thinking, oh, I've just got to push. And then once you're up, it might be something else. It might be bounce or pop or, you were trying to sort of punch the air with your arm, whatever it is that works for that individual.
Yeah.
You're creating those kind of, and it's usually 1 or 2 or 3 things that they can concentrate on. After that, you're probably getting a little bit too much in too short of a period of time. Yeah,
it also highlights though too the clarity of mind that you create with exposure and development of autonomy with a particular task.
And that's to me, in terms of like say sprinting, that's one of the reasons why I think you need to be doing fast sprinting stuff all year round, because you need to get a level of clarity and that idea of automaticity in your execution that you can have that level of thinking happening. Because if you haven't had that and you haven't had the exposure, when you go into races, you actually just haven't done enough of it that you can be really, really comfortable in that environment.
Yeah, and I was actually going to ask this question before you just reminded me of, we think about specificity in training to elicit certain neurophysiological adaptations. We need to think about it the same from a sensory-motor perspective.
Of course,
yeah. Because what's your experience or perspective then of how specific do you need to be in terms of proximity to speed to actually allow it to be transferable? Like, do you need to be at 100% or just...
Well, pretty close. It's not. I think you can clearly get changes, but it's probably at least 90% plus. If you're doing that, then you're getting similar movements, and you're getting, as I said, those 3 parts of the biomechanics, with spatiotemporal, kinetics, kinematics. At 90% plus, you're getting those changes.
Yeah,
and that's where it can get dangerous, is if you get into that sort of, people talk about the gray zone, and for coaches that are involved in sprinting, there was a lot of discussion. It was popularized probably by Charlie Francis, the Canadian coach who was involved with Ben Johnson. For all of his drug saga stuff, he was a very knowledgeable coach and quite successful through that period, drugs aside. But his whole theory was it's either 70% or slower or 90% up. that middle zone he always thought was dangerous.
Yeah.
Now, I don't think it's black or white like that. I think you can use stuff in the middle, but you got to be really careful to think 85% work is probably not going to transfer to maximal speed sprinting unless you're doing something really specific, or you've created some level of constraint that you think there's going to be learning for that individual.
Should we finish it up there, John?
Yeah, I think that probably covers most things. I think just so that clinicians, walking away from this, I think the big things that they need to consider that if you're seeing some sort of aberrant biomechanical output, whether it's in running, whether it's in a skill, is understand, what are the movements that are required. If you need to go do research on that, there's plenty of literature on every movement from walking to squatting to sit, stand, throwing. Yeah. Go and understand those different features that are associated with that at a kinematic and a kinetic level. Go
and connect and talk to coaches. I think that's probably the biggest learning resource.
Yeah, definitely. But as we spoke about with Andrew Dawson, coaches, what they are looking at is sometimes not the same as what a biomechanist is looking at. So you'll get information on both sides that's valuable. Understand the movement.
But also understand the other key factors associated with how someone moves too.
Yeah, well, and then I said, use those to determine, what are their skill sets, biomotor abilities, all of those things, and then start to navigate the problem of, what kind of learning environment do I want to create for this person based on their experience and based on their abilities, so that I can make change. And as I said, it's we almost have to periodize in how much of that should I expose them to, whole part practice, all that kind of thing.
Yeah, and I think also closely tied in with that is we need to think a bit more broadly and holistically about the sensory-motor system and sensory-motor control, because the reality is there are so many factors that influence the behavior of the sensory-motor system that we need to be careful not to reduce it down just to one or two factors. Yeah. There's clearly the key things that we've talked about with regards to the mechanics of the movement, their tissue capacity, and so on. But we need to also extend beyond just thinking about it being related to using specific internal cues to induce potentially more EMG activity.
Yeah. All right. Thanks for joining us.
Thank you. Great.
Today's podcast is brought to you with the support of Strength by Numbers, and in particular, their Assess It system. What is the Assess It system, Jack?
So the Assess It system includes a handheld dynamometer, which they call a push-it, a pull force transducer, and force plates. So this is equipment that we can use to measure force and velocity aspects related to force production. Have you found it useful, John?
It's been extremely useful for us in our clinical practice to get objective data on what our patients and particularly a lot of the sports people that we deal with, and the information that we can use from that to be able to change the management that we do with them.
Yeah, and the most obvious thing is we need to be able to collect data that we know is valid and reliable, because that's obviously going to inform what we do within our clinical practice. I think the other thing that's really useful about the Assess It system is the interface for presenting the data as well. So I think it's really well presented in terms of giving us graphs and also comparison to normative data, so we can get an indication of asymmetries or deficits relative to some of the general population data that's being collected.
If any of this sounds like something or a system that you would like to use in your clinical practice or sports performance setting, we suggest that you reach out to Strength by Numbers and tell them Melbourne Athletic Development have sent you. They'll be able to look after you and set you up with a system that's going to give you more information and allow you to get the best out of your practice.